Hi, I'm Oleg UR3IQ, and today I want to tell you about this synthesizer board. This board is based on MAX2871 synthesizer chip. There are also boards based on ADF 4350 and 4351, and this version has second output with XX1002 doubler, so it can generate frequencies up to 12 GHz. There is first output, which output frequencies from 23 MHz to 6 GHz. The second output frequencies from 5 GHz to 12 GHz. There is also reference input. You can use external reference with this synthesizer. The diagnostic LED, it shows the status of the IRM controller, which is under this screen, and also it shows the log status of the synthesizer chip. There is also micro USB connector, which is used to control the synthesizer and to program it for autonomous mode, and there is a pad for external power supply, which is used in autonomous mode. The synthesizer can work in several modes. There are two big groups. In first group, you connect the synthesizer board to personal computer, and you can use this board to generate any frequency within the specification range, and you can control the frequency and amplitude from the personal computer, and you can also program various synthesizer parameters for the autonomous mode. The second group is the autonomous signal source and the beacon modes, so you can generate any of the four pre-programmed frequencies in the first mode, and in the beacon mode you can use this board as a simple beacon, as a multi-band beacon, and you can also generate several frequencies, so you can scan the band with up to 4 different frequencies. So let's make some experiments and I will show you how it works.
Let's see at the computer screen. We have the control utility running, and we now select the communication port. We can also select the chip type, but it's recommended to leave it in the default auto mode, and the control utility will determine the correct chip type automatically. Now push the connect button. You see the controls become active, and now we can make some experiments and show how you can control the synthesizer board and how you can program it for the autonomous use. Now the synthesizer is running as a simple signal source controlled from the personal computer. You can select the band and the output. The first output is for the frequencies below 6 GHz, and the second output from 5 GHz to 12 GHz. The low frequency limit at the first output is determined by the installed synthesizer chip. When the MAX2871 chip is installed, it can generate frequencies down to 23 MHz. So my frequency counter is old and can count only up to 1.5 GHz, so let's program some frequencies within counter specification, and we see it outputs exactly what we programmed. Some words about frequency tuning. You can just enter the needed frequency from the keyboard, for example, and we see it tunes just in a second after you enter the new frequency. Also, you can use mouse wheel. Set the cursor to the digit you want to change with your mouse wheel, And now you can rotate the mouse wheel up and down, and the frequency will be changed. You see, we can put cursor to other digit and rotate the mouse wheel, and you see the frequency is tuning. Also, you can use the up and down arrows instead of mouse wheel to tune the frequency. The same method works when you set the frequency for the autonomous mode in this group of the controls. Also, you can set the output power. You can set the output power at the synthesizer output chip, and remember that there is an amplifier after the synthesizer chip on this board on the first output, and on the second output there is a doubler chip with a built-in amplifier. But for the second output, let's select the second output, you will have only choice between off and -1 dBm, because -1 dBm is the power that conforms to the doubler chip specifications. So let's return to the first output. Okay, we can turn the synthesizer off. You see, the diagnostic LED is not lit and there is no signal, and we can turn it again on. You can find the tables with the typical output power of the both first and second outputs of this synthesizer on different frequencies in the user manual. If you enter incorrect frequency that is out of the synthesizer specifications, for example 7 GHz for the first output, you see that the background of the frequency input field become orange. It's an indication that you entered the frequency that is out of band. Let's talk about tuning resolution. The comparison frequency of the synthesizer is 10 MHz when it's operated from the internal TCXO oscillator, and it's in 10 to 15 MHz range when you use external reference. But this board uses synthesizer chip which is capable of fractional dividing. So with clever and accurate programming this chip, we can achieve much finer frequency steps than the 10 MHz. In the worst case, it will be 2.5 kHz, but in most cases it's much finer. I will show you how it works. Let's add 100 kHz, and now let's add 10 kHz more, and now let's add 1 kHz more, and you see we have 1 kHz steps, and now let's add 100 Hz, and you see we're almost there. The text field to the right of the frequency input field shows the actual frequency which will be programmed into the synthesizer with the synthesizer chip limitations in mind. So you can check if you will tune the synthesizer with acceptable precision, or if the step size on the used frequency range is not good enough for your applications. We have added the attenuator to match the specification of this prescaler. It's divided by 10, another attenuator, and our frequency counter. So this frequency now is in kilohertz, because we divided our signal by 10, and so we have to multiply by 10 this number. So we have just the correct number in kilohertz. Okay. We have 6 gigahertz, just as we set in our program. Let's tune it a bit higher. 8, 9, 10, 11, 12. As I said before, we can tune it a bit higher. For example, 12 and 24 megahertz. But you should thoroughly test if it works stable and if it matches your requirements. So, let's try to program some frequencies for the autonomous mode, and let's make some experiments with the autonomous mode. The frequencies for the autonomous mode are programmed just as we set the frequency and output level and select the band for the signal source connected to the personal computer mode. So let's program some frequencies. For instance, 10 gigahertz. We will use the second output just because we have already connected all the attenuators, dividers, so we will save some time. Okay, we have entered different frequencies for the different jumper settings on the board. Currently we have no jumpers installed on the board, so when we power up our board in the autonomous mode, we should have 8 gigahertz output. And then I will show you how the frequency can be changed on the fly. Let's save the programmed configuration to our board. We will push the save button, and we see the control board utility says that configuration was saved to our flash memory, and also it shows the note to remind that autonomous mode is activated only with external power supply. So if you connect this board to personal computer, you will enter the signal source and programming mode, and you will not get the programmed frequencies for the autonomous mode. You should connect an external power supply to enter autonomous mode. Okay, let's disconnect the board and see how it works. I will turn on the external power. You see the LED flashes several times indicating the controller is running and the firmware check is okay. And now it leads, indicating the lock condition of the synthesizer. We see the 8 GHz frequency, just as we programmed into F4 input field, and we see there is no first jumper and there is no second jumper installed. So we have the correct frequency. Now I will show you how you can change the frequencies on the fly. We have 4 pre-programmed frequencies. So I will short the first jumper, see the frequency. We see 7 GHz, and now I will short the second jumper, and now we see 6 GHz. So you can change the frequencies on the fly. Now let's see how the beacon mode works. So we will disconnect our board from the external power supply and connect it to personal computer for further programming. We have connected our board to the computer, and we see the last used configuration here. Now let's enable the beacon. Let's set the frequency in the high frequency band range, so we can monitor the beacon with our shortwave receiver. Let's set it to 2854, for example, megahertz, and we should use the first output for the shortwave output. We will add to the text the solid tone for 5 seconds and the delay for half second. So the beacon will send test DUR3IQO 5-second tone and half-second delay. It will send the text at 15 VPM approximately, and it will use the 28 and 44.44 megahertz frequency, because we have no jumpers installed on the board. Let's save the new configuration, disconnect the board from the computer and connect it to external power to see how it works.
Here is our setup for beacon mode test. We have the synthesizer board, first output connected through the two attenuators to the shortwave transceiver, which receives the frequency we have programmed before. So let's turn on an external power. We see the synthesizer board starts, and now so now we hear the beacon works. We hear the text we programmed. We hear how two macro, one for sending mark and one for sending space works. So you can build a simple beacon, you can build a multi-band beacon, you can build a multi-frequency beacon. There is also two parts, and here we can get the band selection or frequency selection signals, so you can switch an external amplifiers or switch an antennas.
As I said before, you can also build a simple multi-band, multi-frequency beacon using the frequency scanning feature. When you enable the frequency scanning by checking the enable scanning checkbox, the board will send the text, the beacon text on the frequency selected by jumpers. Then it will select the next enabled frequency, F1 in this configuration, and then it will switch to F2 and then to F3 and then to F4 again, and so on. It will send the text on each of this frequency and switch to another one. If we will turn off any of these frequencies, it will not switch to this frequency, it will skip it and switch to the next available. This mode also allows you to make some multi-frequency test generator for experiments. For example, you can program just a solid tone for 5 seconds, for example, and we will program 8 gigahertz here with the second output, and we will see the 8 gigahertz 5-second tone, the 10 gigahertz 5-second tone, and then the 7 gigahertz 5-second tone, and so on. So let's save this configuration, disconnect the board, connect it to external power, and see how it works.
So let's turn on an external power. You see the diagnostic LED leads several times, and now we see the frequency change according to our settings. We have one cycle passed, the second cycle 8 GHz 5 seconds, 10 GHz 5 seconds, and 7 GHz for 5 seconds. The 6 GHz was skipped as we programmed in control utility software. We see how this board works in different modes, how you can program it for autonomous use, and you see that it can be used as a signal source, as a pre-programmed signal generator for various transverters, for various converters, and also it can be used as a simple beacon. You can use it to tune your antennas, to experiment with propagation, and so on and so on. I hope this video was useful for you. I hope you enjoyed, and I hope you will enjoy using this board, this synthesizer board.
See you next time. Goodbye.